Things. So in this one, let's take some matrix. Let's say, for example, matrix A will be equal to this 3 by 3 matrix, 3 2 1 1 5 1 4 0 2. And so this all in all is a matrix. We can have some vector x such that ax equals b, and let's say b would be a vector of three entries. Let's say 1 1 1. All right. And so now what we know is b is on the right side of such an equation. So this equation, it states that if we multiply this matrix A by some vector x on the right side, the result will be vector b. And when we multiply by x on the right side of A, well, what it means is basically x is composed of three components here. It should equal to the number of columns in A, because they scale the A's columns. That's the job of x here. So this is the basic matrix vector equation. We'll be talking about something called the Cramer's rule here, which tells us how to use determinants of matrices in order to get these three parameters explicitly by a formula without performing, for example, elementary operations on A as a matrix. Although, of course, one could, for example, as part of getting a determinant, do elementary or row operations. But let's say we won't do that, and we will simply take a determinant without using any row operations in the process. So how would this play out? Well, we can have different questions. So just to make it straight, make it clear, to set the record straight. So ax equals b. Well, that means that x is some three parameter vector, as I denoted here. That's the same that I mean by this x here. So either I say x on its own, or I can put an arrow there, and this is the content. This is the three entries it has. So x1, x2, x3. So when you multiply the a by it, what it basically means is we have 3 to 1 is multiplied by x1, then the second column is multiplied by the second entry x2, and add to it 402 and multiplied by x3. That's the idea. So now our question could be, we don't want, for example, to get all these three entries of x. Let's say we only want the third entry, for example. So the question is how this plays out. How can we quickly calculate it without doing row operations? There's something called the Cramer's rule. What it says is we want to only get the third entry. It's going to be equal, so x3 here, exactly as we wrote here, will be equal to the determinant of a matrix that I will, for example, denote m sub 3 over the determinant of the whole A. So we will, in any case, have to get the determinant of this matrix. And determinant of M3, well, M3 will be a matrix created from, if we want, entry x sub I, so ith entry, in this case the third one, we will replace the column number I in A. And that will create M sub 3 matrix. So M sub 3 matrix is created from the matrix A by replacing the column number I by B. That is the idea. So when we want M3, we will keep the first two columns intact, and the third column will be replaced by this 1 1 1. So that's the whole idea. All right. So how I can say in general, this is xi, so the 1, 2, or 3 entry number 1, 2, or 3 of x will be equal to the determinant of m with the column number according to what I is, replaced in A by B, which is the right side of our vector matrix equation. So let's say the concrete question here will be, what is the third entry? So all we will do is basically get mi. So mi would be 3 2 1 1 5 1, and third entry is 1 1 1. And we have to follow this formula. So to get the third entry, we have to put it for, so this is m sub 3, because the third column is replaced. So how does this work? Well, as was shown, all we have to do is just write it out according to the rule. So x sub 3 is the determinant of m3, and m3 is a with the third column replaced by the right side of the equation, the b. So that is the determinant of 3, 2, 1, 3, 2, 1, 1, 5, 1, and then put the 1, 1, 1 there, over the determinant of a in the default form. So 3, 2, 1, 1, 5, 1, 4, 0, 2. And that is as follows. It's actually equal to, we can, for example, do it according to the first row. Now, doing the determinant, I won't explain it closely, otherwise we would use a lot of time for explaining that. We've already used a lot of time for explaining the things we've talked about so far in the last 6 minutes. So to do this quickly, it's simply as follows. It's going to be 1 times 1 minus 5 minus 1 times 3 minus 2, so that's 1, plus 1 times, I'm just doing the determinant of the upper matrix, so that's plus 1 times 15 minus 2, that's 13. Over, and now the determinant of a itself, which is 3 times 10 minus 1 times 4, which is 4, plus 4 times 2 minus 5 minus 3. So this number, whatever it turns out, well, to be, we don't have much space on the screen now. I'll have to delete this. So let's just take care of this number. So it's minus 4, minus 1, plus 13, which is 8, over, and this is 30, minus 4, minus 12. So it's 14. So this can be further divided by 2, 4 over 7. So the third component of x, according to this, should be 4 over 7.